Good morning, good afternoon, good evening. Hope you're all well. Today we are going to discuss the 29th problem in the TLE Eliminators CP sheet, 800 rated problems. The problem name is Everybody Likes Good Arrays. So let's start. Let's start by reading the problem statement first. An array A is good if for all the pairs of adjacent elements AI and AI plus 1 are of different parity. Note that an array of size 1 is trivially good. You are given an array of size n. In one operation, you can select any pair of adjacent elements in which both the elements are of the same parity, delete them and insert their product in the same position. Find the minimum number of operations to form a good array. We need to output the minimum number of operations. So let's take an example to understand the question. Let's take the first sample test case. So we have elements 1, 7, 11, 2 and 13. So these both elements are of same parity. Parity means like odd and even. If the number is odd or if the number is even. So these both are odd numbers. So these both have the same parity. So what we can do is we'll just club them up and write 7. Now these both numbers also have the same parity. So we'll again club them up. So now these both numbers have different parities. So these both numbers can be a part of our good array since they both have different parities. Now this pair also can be a part of a good array because these both also have different parities. So this is our good array. So the number of operations required were 1 here and 1 here. So our answer was 2 here. That's what we need to do. So let's see some properties. If we got odd elements and we multiply them with odd, we'll always get an odd element. But if we have an odd and we multiply it with even, then we'll get an even element, and even with even is obviously even. So since we need the minimum number of operations, we will group all the numbers with the same parities. Right? Like this is one group, this is one group, and this is one group. So in order to group these, we'll require 2 operations. So this is already one group and this is already one group. So the number of operations were 2. Similarly, let's take the last sample test case. Now the groups of same parities are this, this and this. So the number of operations would be 2 here, 1 here and 0 here. So the sum is 3. This is one group, it will require 2 operations. This is one group, it will require 1 operation. This is another group, we don't need any operation for this. So our answer is 2 plus 1 plus 0, that is 3. That is the answer here. So I hope you got the intuition. Now let's write a little bit of code. We'll have an input n and we'll have an input array. Initially we'll have an answer variable set to 0 and our parity set to 0. That means we are starting with even parity. So we will traverse over the array. If the parity of the current equals to the parity, then we will increment our answer. That means we need to group the elements. Like these both elements need to be grouped together. Otherwise we'll reverse the parity. Right? Suppose like parity is 0, then we'll make it to 1. If it's 1, we'll make it to 0. So I hope you got the code. Now let's move on to code the same. So I have my boilerplate code here. We'll be given an n, that is the size of the array, and we'll make an vector of size n. We'll take all the elements as input. Now we will define an answer variable that is initially 0 and we'll define a parity variable that is initially 0. Now we'll check for the parity of the first element. If that is odd, then we'll set our parity to 1. Otherwise it's 0. So we'll start from the first index. If the parity of the current element is equal to the parity we are having, that means they form a group, and we will increment our answer. Otherwise we will change our parity. Right? So in the end we will just print our answer. That's the code. Now let's try for the sample test cases. Answer is 203. That's the correct answer for the sample test cases. Now let's try to submit it. and it got accepted. That means our solution and our approach is correct. I hope you understood the problem. Comment down what was your approach for solving the same problem. The solution link would be in the description section. Do check it out. Also, this is a playlist for all the problems in the CP sheet. Do check out all the other problems as well. Like the video, subscribe to the channel and share it with your friends. Thank you.